Ben Franklin said something and made a quote. I assume he made this quote. I wasn't old enough to know Ben Franklin, but I'm close. Okay, he said, "Tell me and I'll forget. Teach me and I'll remember. Involve me and I'll learn." We hope you learn a lot in the next 2.5 days. And that's one of the things that what we hope we can go on with. Okay, Dan said I was from Burke, and I live on my grandfather's homestead place. The homestead is right here, and he homesteaded there in 1904. We had in 1970, this is what the pastures look like on the 400 acres that I live on. Me and my wife operate that operation. Here's the 2012 vintage of the operation and the place, the paddocks that I have set up and that type of thing. The whole place is all in grass right now. Some of it isn't good grass, a lot of brome grass, and some of the go-back land. We got all kinds of situations there. Things have happened, and it all started when my grandfather homesteaded there. He had to plow up some land. It was all native range. And in 1904, he homesteaded on that quarter, and the first thing they told him was, this is a government program. You got to plow in order to prove up on your homestead. And that was along the creeks, the Ponco Creek that I live on. He had to break up that land that was not suitable for cultivation, class 6, class 7 land. And he did that. Very productive for a few years. And then things started going different directions from there. I'll back up here a little bit and we can. This isn't a new thing, this conflict between grass and crop settings and situations. The Bible tells us that Abel was a keeper of the sheep and Cain was a worker of the ground. And a little later on, as they grew older, Cain rose up against his brother Abel and killed him. So there was a little bit of conflict back there, and we see this conversion of land was mentioned way a long time before we even thought about being concerned about it. And we thought we needed to keep doing that, apparently, because of development. In other words, we needed to make the land better and produce more. And that was the thing that went on. Why did we have to do it? Was it, in the 1950s and 1960s, they said we have to feed the world, and we're responsible for that, and that's something that went on. Maybe there was some other motive behind there, a little financial motive. I don't know. The chief, Richard Manning, an individual, said that some of the things we need to feed a lot of people, and everything, the technology and everything went towards production. And that technology and the knowledge that we learned and had was kind of put on the shelf. And why it remains on the shelf is a good question. He went on to say, the key to the core is a core of national scientists who compare a cosmopolitan education with knowledge honed through contact with field conditions. These people will be the appropriate conduits of technology out there. Here's one that I thought was kind of interesting. Agriculture ought to copy the design of American tallgrass prairies because the prairie can sponsor its own fertility. You think about that a little bit. Can a native prairie sponsor its own fertility? How many think that it does? You don't have to fertilize native range. It keeps on growing and growing. Yeah, we got some positive head shakes. Yep. Okay. Here's a proof or an example that we found on the Rasmussen Ranch out south of Belvedere this August. This is a loamy soil right here, and it's a cube silt loam. That's the way it's mapped. Both of these profiles are the same soil and was mapped identically. The one on your right was broke in the 1940s, and it's been farmed, planted back to alfalfa and crested several different times, tore back up, hayed and grazed, then tore back up and reestablished again. The cropland site, the guys in the NRCS and Jeff's over there, Jeff Hemingway, was out there and led a group of people to do this testing of the soil. And they picked, on this cube site, they picked 3 or 5 different sites, and they put one of these rings down, drove it in the ground, and then put an inch of water on there and timed it. And the infiltration rates are recorded here. Took 3 hours and 57 minutes for one of the rings to soak that water into the ground. The other ones went 34 minutes, 37 minutes, 52 minutes, and 2 hours and 29 minutes. That was on and this was oat stubble. It was planted into oats this year. And that's what the interesting thing about it was. So we got the fastest time is 34 minutes. Okay, here's the native sod across the road. Never been broke. Hasn't been plowed or anything else. It's been in native grass all the years since the beginning of the times. The first site took 30 seconds for that same inch of moisture to be soaked in to the soil profile in that 6-inch ring. One took 2 minutes and 25 seconds, 34 seconds, 50 seconds, 6 minutes and 47 seconds. 6 minutes, I guess, is probably the slowest one on this native grass site. Now, this is, I don't know whether you can see this in here, but the topsoil, and I shouldn't say topsoil, the black soil comes down to about right here, over here. The rest of it has disappeared. And I don't know how it disappeared or what the deal is, but the topsoil or the black soil comes down to about right in here. Since the 1940s, we have changed that soil that much. Infiltration-wise, we go from hours and minutes to minutes and seconds of infiltration. My question is, after I saw this, can we create our own drought? We get a 2-inch rain, what happens to the other inch over here? Runs off, huh? Yeah, goes someplace. It doesn't go in the soil that fast. Okay, right here, if we get 2 inches in an hour, what happens to the water? Goes down. What do plants need to grow grass and make vegetation grow? And we're short of that this year, right? We're really short on it. Okay, that's the thing. That's the difference right there. We need to talk about some grazing terms. And that's one thing that I found out that's really interesting at the grazing school. Not everybody understands the same terminology, and we use different terminology. Each one of us as an instructor may say a term, and we have a different meaning than you would understand. So we need to look at some of those things. What is rangeland? It has indigenous vegetation, climax or subclimax, is predominantly grasses, grass-like plants, and so forth. Notice the new definition of rangeland, and these definitions came out of a paper that was put out, I think, about a year and a half, 2 years ago, where all the scientists got together and they agreed on definitions. Rangeland, to me, when I went to college in the 60s, it was native vegetation. There wasn't introduced grasses in there. Now the definition doesn't say anything about, it's just grasses out there. So we need to take a look.
It's indigenous.
Yeah, okay. And that could be native to where? To that site or to a country or a nearby place, that type of thing. See, and that's something that's kind of interesting. But anyhow, just keep in mind, and you want to ask the question. If you don't understand what the statement that was said, ask about it and ask what the difference is. Stocking rate. What is stocking rate? Well, it's an animal to land relationship over time. Animal unit months per acre. You got animals, you got months, and you got an acre. And that's what a stocking rate is all about. Stocking density, on the other hand, is an instantaneous measurement. Animals per acre at this given point in time. The stocking rate is different than the stock density, and you may have 300 cows on 1 acre. That's stocking density. But how long are they on there gives you the idea of what the stocking rate is. Overgrazing. The old terminology was overgrazing can't happen in one bite or one occupation of an animal coming along and grazing. It will kill the plant or die back or something over a period of years before a plant becomes overgrazed or a site becomes overgrazed. Today, our terminology, some of the folks talk about a plant being overgrazed when it's bit twice in one occupation, that type of a thing. The second bite may create an overgrazed situation. Talk about that and ask the question, what are you talking about when you say overgrazed? That's the important thing. An animal unit, and we're going to get into that a little bit more later on, but an animal unit by definition is 1,000 pounds of animal. So is a 1,200 pound cow an animal unit? Is that one animal unit?
1.2.
Yep, you're on the right track. Actually, it's 1.15, but you got the idea there. Yes, and make sure that. Sheep. How many sheep does it take to make an animal unit?
2.5.
How many?
2.5.
2.5. How about 5? Depends on what they weigh. You know, that's the interesting thing about it. But that's what we need to ask in those kind of questions. Make sure we know what we're talking about before we get going here. Stocking methods. There's a lot of methods of stocking. And the old term was grazing methods. But now the new definitions say we should be talking about stocking methods. And like deferred stocking, mob stocking, rotational stocking, set stocking, management intensive grazing. Jim Garish, the guy, came up and said, he coined that phrase MIG. Well, maybe it should be MISS. There we go. I don't know. We gotta just, that's kind of interesting how we can look at that. You're going to hear a lot about diversity, biodiversity, diversity. And that's the key. And that's when you got a lot of good, healthy plants and a whole good, nice mixture of it, that's diversity that we're looking at. And that's, you're going to learn a lot about that here today. Okay, designing grazing systems or stocking systems for your operation. Everyone is different. And it's like that spider web right there. It's you got to put them in, you got to design them for yourself, your operation, and the conditions that fit there. For example, here we got 2 rotational grazing systems here and 2 different operators. Which one looks better?
You have to know more about it, probably, to say that.
Dang, you're good. Hey, that's great. Yes, you need to know the difference. Maybe this guy just moved the cattle out of this one here, and next year this one will look like this side, and this one over here will look like this. You know. I mean, it's that's something that you might want to look at. You need to know the details of what you're talking about and what you're looking at. Well, when it gets time to graze, climate is what we expect, according to Mark Twain. Weather is what we get. Well, the climate said, hey, we're supposed to have a lot of growth and everything else according to average precipitation. But this year, things didn't happen that way. So we end up with a little difference in plant community. These 2 sites are about the same ecological sites, and they're about 1/4 of a mile apart. Why are they different, and why do they look different? It's because of the plant community that we have on there. And we want to kind of consider this and take a look at this concept here. How do plants grow? What do they need? Sunshine, right? And they need leaf area to capture solar energy, just like these solar panels capture. And as we go along, this guy put on just a few solar panels on his roof. This fella put the whole roof in as solar panels. This could equate to the amount of vegetation down here and the amount of vegetation over here. Now, what happens? What's the difference? Which one captures the most solar energy? It's a no-brainer, really, isn't it? The bigger one up here captures more energy. We got more grass, more production down here than we have over here and here. And that's the thing that we need to keep in mind. We got to have that leaf area out there in order to keep the production going. And that's important. Figure 1 here shows when an adequate residual is left after grazing. In other words, here's your graze line, and you clip the top parts off of the plant. Okay, when the sun continues to shine, there's enough leaf area here that this plant just keeps on growing. Very little is pulled back from the energy reserves down here. You got an adequate residual plant leaf area there, solar panel if you will, to keep on growing. Over here, if you graze to this height, the same plant, if you graze down here instead of up here, you have an inadequate residual, and all of a sudden your carbohydrates and the regrowth on that plant has to come from the bottom, come from the roots, and from the stored energy right down in here too.
How long is it going to take? I might be jumping ahead a little bit, and if I am, just back me up, but say like this year we've all been dry, pastures have probably been overgrazed, some or quite a little. If I normally take it to that first picture where you want it, and this year I decided I had to take it down to that second picture where it is, how long, if I keep my grazing practices the same, how long is it going to take that plant to recover to the health that it was?
We're going to get to that. Next slide, I think, if I remember right. Okay, basically what we're doing is we always read in the literature you got to have 3 leaves before you start grazing. You know, that's in the spring you should have 3 leaves. 1, second leaf, third leaf. And then you're about ready to graze. And what happens when you cut it off here or you cut it off here, and how long will it take to recover? Well, we've got a little bit of literature right here. If you have residual, this is according to Jim Garish's information that he got from Missouri. When he was down there, he worked on some research there. Here's your residual height. You graze it down to 2 inches. Okay, your growth rate in pounds per acre per day. Now, keep in mind where this stuff came from. It came from Missouri. Is South Dakota different than Missouri? Is Harding County different than Gregory County? Yes, yeah, it is. So we got to take this with a grain of salt and make it work to fit it together. But the important thing is this thing shows that about 30 pounds per acre per day of production is developed when you take it down to 2 inches. If you leave a 6-inch residual, you're up to that 55 pounds, something like that, on the amount of forage produced based on the height that you. So it's slower growing if you take it down shorter. Now here's another example: days until the next grazing. 45 days up here, 25 days down here. You take it down to that same 2 inches, you got about 40 days, 39 days before you should, you could come back and regraze. 6 inches of height, you got about 30, 20, 32, something like that. Around that 30 days. Now here again, that's in Missouri, and we don't know how the weather was down there when they'd done all this research either. You need to deal with some different things in grazing management. And this is where the picture gets big. You got some people to help, or some things to help you, like carrion beetles, dung beetles, all of the kind of bugs and things in the soil. That's the things that are important and ready to help you out a little bit. But you also have a few other things. You got some personal goals. And one of those goals was, I need to attend the South Dakota Grazing School. So I can't be out there doing things on my place while I'm here at the grazing school. Or maybe I need to take a vacation. I have to schedule a trout fishing trip here coming up here shortly. So there's a lot of different things that need to be fit into those goals. You have your farm or ranch goals, and you got, guess what, government program goals. How many are involved with a government program? Like CSP, EQIP, CRP? Jeez, look at the hands. Hey, I guess maybe we kind of understand they have goals. They got rules. That's some of the things that we need to pay attention to. We got to manage our time. Can we make it all fit together? Hey, and do we have money to do what we need to do? We need to look at that. And here's the most important one that I think is the most important about grazing management. You need to have a strong desire to leave the land in a better condition than when you got it or found it, that type of thing. That is the key and critical thing that will carry you farther with a good grass management program. That desire and that inward feeling, is it right or not, what I'm going to do. Tools for the trade. Jim Garish said this: the purpose of a college education is learning how to think, not what to think. We need you to learn that type of a thing. Education is important. Some other tools that we need to have are water developments, fences, planning, stocking systems, and stocking methods. Those are the things that we want to look at. How important is stock density? Hopefully over the days here, we'll answer that question for you, and let you decide how important is that stock density. How many animals or how many pounds of animals can you put on an acre or into a pasture? Do you burn or don't you burn? And that's something that I think is, I was an anti-burning person until about 3 years ago. and this is on my place. This right here is a solid stand of brome grass and a little bit of bluegrass in there, and I thought that's all that was really in there. Later, here's what it looked like, different view of it, but the same location. On May 7th of 2011, we burnt several patches on the place. Here's the same location as you see right here on August 29th. Keep in mind, these are 2011 pictures. That was the year it rained. Okay. Another one, you get a lot of diversity coming back in. Look at that. Tall, the warm season grasses back here. Forbs came in to beat the band. They didn't come in, they just got released from the thatch of brome and bluegrass that kind of inhabited them there. Little wreck versus big wreck. Everybody says I should spend a little time on this. Well, I don't know how you can spend too much time on a little wreck. Okay? Here's my situation. I had on June 21st, there was 5.5 inches of rain in 2 hours. And my 110 head of yearlings were in this paddock. And you can see right there, they kind of made a muddy mess out of it because in that 2 hours, it rained right in that time frame. We moved them out of there that next day. And they came out just as they were scheduled to come out. But I was sick to see how black that thing looked. They churned it up and worked it up to beat the band. On August 29th, you can't see much of a difference. Actually, you can see a difference, right? A line right through here. This side is a little bit greener than this side over here. The little wreck. If I would have had that situation and I'd had it on the whole quarter of land, I'd have a big wreck. And that's why I'm saying, hey, you can manage your wrecks. You can have little ones, experiment on a little scale and work from there. That's something that I found and learned over the time. It's cheaper to have a little wreck than a big wreck. That's something that's important. Water systems of all types, I got all kinds of them on my place, and Judge will tell you a little bit more about water systems later on in the session here. But portable pipe with above ground, or portable tanks with above ground pipe furnishes some of the water to my paddocks. Permanent dam, I have them, but they're for emergencies. They're fenced out. And we got some permanent tanks here. But livestock dams, any kind of water, everything's fenced out so the cattle can't get in it. So it helps my foot rot problem immensely. And then there's some good electric fences, and then there's kind of some bad ones. This one right here, notice the solar panel. We got a broken panel. The cow stepped in it, and in fact they upset this thing, and it wasn't doing real well. The solution is to take it out of the pasture where the cattle were and put it on the neighbor's side of the fence. That's why I took this picture. It was kind of an interesting thing there. But that's how they fixed the problem. Notice this cost-shared fence. And just take note of this thing. See this H brace? This is a cost-shared fence. And you know you got to have a good corner post and a corner brace and all that. They require that to get cost-shared going things. Well, this H goes this way, and the fence goes 90 degrees in the other direction. It's interesting, isn't it? Notice how that one post is starting to bend over already. And then you can have poly-wire fences, portable ones, and I have a lot of those. Wind it up with an 18-volt cordless drill. When you're done with it, I move the fences right along with the cattle. Minerals to balance a ration is something that you're going to learn quite a little more about. Jim and Dan will tell you a little bit. Ken has a presentation on that to talk about balancing the ration. I get all kinds of help. This is Dan Rasmussen out. He's out clipping grass on his ranch. I just put that picture in there to prove that there are ranchers that do clip grass. Yes. And this is my granddaughter this summer. She got the job of moving the yearlings and putting the mineral out, and I kind of just watched and took pictures. And I think that's an educational thing. Hey, and the important thing was she texted her friends in Mitchell and told them what she was doing. And they wrote back, texted back, and said, "So what are you doing now?" And we're sitting here with nothing to do. We're bored. And she's out moving cattle and having fun out there. And I thought that was interesting. Part of the educational process. Involve other people, I think, is the key there. Well, you have people, and all individuals excel in one thing. And we have a lot of good cattlemen, and we have a lot of good grass managers. But seldom do you run into a good cattleman that is an expert and a good manager of both. And that's what we want to try and get and prove and show, that that's what some of the things that are real important. We need to get that and instill so you're an expert in both fields. They say, Richard Manning said, change lies in the heart of a dynamic system's ability to survive upheaval. That which we seek to insulate from change has endured so far only by changing. We got to change with the times. We got to make things work. And that's one of the important things that I see is what we need to learn is how do we change and still maintain that conservation ethic that we have to protect our grasslands. Thank you for your time. Are there any questions? Do I have time for a question?
Why did you burn off? Why did you graze on?
I wanted to find out what fire does to a plant community. I've grazed that brome grass and I've grazed it, and all it does is get thicker, it seems like. Now I'm not doing it right. And with fire, yes. It isn't gone completely, but we kept it from making a seed head for 2 years as a result of that. And that's one of the things to help stimulate that natural plant community. In the previous years of time, I think we had a lot more fire than what we have today because we got good volunteer fire departments. That's where they're too good, almost. You know, that's one of the things. Yeah.
You kind of halfway answered mine with his, but how long before that brome grass or bluegrass starts to come take over again?
After a fire?
Yeah.
I don't know.
You said it was 2 years before it started to show up again.
Well, it showed up. It showed up right away, but it didn't make a seed head, so it was hurt. And now, in the meantime, the warm season grasses and the other native grasses popped right back up. It's all deals in how you time your fire and when you burn and that type of thing.
I assume too your grazing practice is a lot different than it was, say, 10 years ago or 20 years ago when that got established.
Right. Yeah. This drought now, all the brome grass, and you've probably seen that out there. The brome grass out here that you're going to see out here today is almost totally brown. Mine down in Gregory County is totally brown. But up comes the tillers after the yearlings left in August. Here comes the tillers up, and I got little green tillers all over the pastures like that, where the brome grass is. Should have kept them and run them through again and grazed that off, and I'd have probably whacked off a whole bunch more, weakened the plants a little bit more. And that's you're going to learn a lot about that and how that works here in the next couple of days.